The power rule can be used to rewrite a logarithm, and then converting this expression to exponential form can simplify it. So let's say we had the log of base 3 of 9 to a power of negative 2. We can use the power rule to move this exponent negative 2 to the coefficient of this term, which would give us negative 2, the log of base 3 of 9. And now we can convert with the exponential form in order to simplify this to negative 4. But let's start at the beginning and work our way through this process. Let's say you are asked to expand and simplify, if possible, the log of base 3 of 9 raised to a power of negative 2. So here's what we want to do. Step 1, move the exponent of the argument, which would be negative 2, to the coefficient. So that would give us negative 2, the log of base 3 of 9. And now we want to set the logarithmic term here equal to y. That way we can now convert the function to exponential form. So we take our base 3, raise it to a power of y, and set that equal to the argument 9. And now we want to solve for y. So we change 9 to its equivalent 3 squared, showing us that y is equal to 2, which means that the log of base 3 of 9 is equal to 2. So we can replace this term here with its equivalent value, positive 2. So this shows us that the log of base 3 of 9 raised to a power of negative 2 is equal to negative 2 times the log of base 3 of 9, which is equal to negative 2 times 2. And now we want to evaluate this expression. And negative 2 times 2 is equal to negative 4. So we find that the log of base 3 of 9 raised to a power of negative 2 is equal to negative 4. And that is how we go about using the power rule to expand terms. Let's now have you try a few practice questions. Expand and simplify if possible. Question number 1. The log of base 2 of 16 raised to a power of 3. Question number 2. The log of base 5 of 125 raised to a power of negative 6. And question number 3. The log of base 6 of 36 raised to a power of negative 2x. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We are given the log of base 2 of 16 raised to a power of 3. Step 1, move the exponent of the argument, which is 3, to the coefficient. So that would give us 3 times the log of base 2 of 16. And now we want to set the logarithmic term here equal to y, giving us the log of base 2 of 16 is equal to y. This now allows us to convert this function to exponential form. So we take our base 2, raise it to a power of y, and set that equal to 16. Now we can solve for y. 16 is equivalent to 2 raised to a power of 4. This shows us that y is equal to 4, which lets us know the logarithmic term is equal to 4. So we can replace this term with its equivalent value 4. And now we can evaluate the expression 3 times 4, which is equal to 12. So that we find that the log of base 2 of 16 raised to a power of 3 is equal to 12. That is the answer to question number 1. Let's now have a look at question number 2. We are given the log of base 5 of 125 raised to a power of negative 6. Step 1, move the exponent of the argument, which is negative 6, to the coefficient, which is negative 6 times the log of base 5 of 125. And now we want to set the logarithmic term here equal to y. This will allow us to change this to exponential form. So we take our base 5, raise it to a power of y, and set that equal to the argument 125. And now we can solve for y here. 125 is equivalent to 5 raised to a power of 3. This shows us that y is equal to 3, which means the log of base 5 of 125 is equal to 3. So we can replace the log with its equivalent value 3. And now we can evaluate the expression -6 times 3, which is equal to -18. So we find that the log of base 5 of 125 raised to a power of -6 is equal to -18. That is the answer to question number 2. Let's now have a look at question number 3. We were given the log of base 6 of 36 raised to a power of -2x. Step 1, move the exponent of the argument, -2x, to the coefficient, leaving us with -2x times the log of base 6 of 36. And now we want to simplify the logarithmic term a bit further. So we'll set that term equal to y, which will now allow us to convert this to exponential form. So we take our base 6, raise it to a power of y, and set that equal to the argument 36. And now we can use this to solve for y. So we change 36 to its equivalent 6 squared, allowing us to see that y is equal to 2, which means that the log of base 6 of 36 is also equal to 2. So we replace this term with 2, leaving us with -2x times 2. And now the last step, we want to evaluate the expression -2x times 2, and that would give us -4x. So the answer to question number 3 is the log of base 6 of 36 raised to a power of -2x is equal to -4x.